Because we have 8 seconds until we go live. Which one of those was correct?
Yeah, for now we're live.
We're live.
Hello, everyone. Welcome all on Data Phoenix webinar. Today we will speak about computer vision, and with us Jacob Marks. He is a ML engineer and developer evangelist at VoxelGPT, and he will talk about how you can use FiftyOne plugins for create your customized computer vision application in more interesting way. Before I give to him microphone, I want to say that you can ask the question using Slander, which we added under the video on our site, the plugin for it, and we will answer for all your questions in the end of Jacob presentation. So Jacob, I give to you microphone, your stage.
Awesome. Thanks so much, and thank you for having me. It's a pleasure to be here. So today we're going to be talking about building custom computer vision applications with FiftyOne plugins. For those of you who don't know what FiftyOne is, we'll talk about that. We'll talk about what FiftyOne plugins are, and then we'll talk about how they can be useful to build customized applications. So starting with just brief background, who am I? So my name is Jacob. My background is actually in math and physics. I finished my PhD about a year and a half ago, and I transitioned into machine learning and computer vision around then. And since then, I've been at VoxelGPT, which is a company focused on data-centric AI and computer vision, and I've been a machine learning engineer and developer evangelist. Who is VoxelGPT? So we are the lead maintainers and the creators of the open source FiftyOne toolset. We'll talk a little bit more about that later, actually a lot more. The company was founded by Jason Corso and Brian Moore, both of whom have extensive experience from industry and academia in computer vision and machine learning more broadly. And currently the team has 25, I think a little bit more than 25, driven, sharp, and talented computer scientists, computer vision experts, and just general go-getters who are supporting thousands of open source FiftyOne users and a bunch of Fortune 500 and Fortune 100 companies. So our mission at VoxelGPT is to bring transparency and clarity to the world's data. So that's a very big mission. That's a large goal. But the way that we approach that is through data quality and data-centric workflows. So nothing hinders machine learning systems more than poor quality data. So garbage in, garbage out. And what we do is we build a tool set that helps you to, through data-centric workflows, understanding your data better, improving the quality of that data, iterating with your data and models to make your data better and make your models better. Now, today's talk is going to be about something slightly different, which is enabled by the FiftyOne platform, the FiftyOne toolset, but it's actually a little bit more geared towards creating applications. So on the left here, we have a demo from Hugging Face Spaces. So this is using Gradio, and it shows just what it looks like to have the Fuyu 8B model from Adept that just came out, where you put in an image and you ask a question, and then you get an output. And the output is great because it's Fuyu. It's pretty detailed, but this is not as interactive, maybe as we'd like. It's pretty static in that you have the ability to put in maybe an image at a time, and you have one model, and there's not that much flexibility in this way of interfacing with this particular data and model. On the right-hand side here, we have something much more interactive where you can dynamically work with different workflows, multiple models. You can pick and choose which model you want to use at any one time. You can choose which images you want to look at, and you can switch between data sets and between media files incredibly easily. Here's another example. So this is on the left-hand side, we have DALL-E the text to image generation model from OpenAI. This is Dolly 2 here. And the way that people typically interact with it is by typing a text prompt into the search bar at the Dolly website, and then they get a couple of examples. And that's fine, but what do you do once you have those examples? What do you do once you have those images you've generated? If you like them and you want to do something with them, if you want to curate them, to save them for the future, to save that metadata, um, well, on the right-hand side, we can do just that, and not just with Dolly 2, but with a wider array of models. You can add these images that you're generating with whatever hyperparameters you'd like, directly to your data set or your collection. And this just allows you to much more dynamically and flexibly interact with your data and models. And these are just two examples here, but these are examples of how using the 51 toolset allows you to build what I'm calling these custom computer vision or more generally AI applications. And that's what we're going to talk about today. So the agenda for today's talk is we're going to start with some motivation. Then I'm going to talk to you about data-centric AI with 51, what that looks like. Um, then we're going to talk about the 51 plugin framework. So what are these plugins that allow you to extend the functionality of 51? And we'll start. The next thing we'll do is we'll talk about building computer vision applications using this plugin framework. And the final step will be what comes next. How can you level up your applications using these plugins, and links for you and resources to help you to get up next step on your journey. So we're currently in the middle of an AI Cambrian explosion of sorts. So there is a massive influx of new papers every month in machine learning, AI, computer vision, all these areas. And here on the left-hand side of this slide, we have an image that comes from, in this case, Reddit, which has a curve fitted to all of these data points of the number of papers that are coming out from ML and AI. And this is before even 2022 when ChatGPT came out. So things have accelerated even more since then. But there's basically an exponential growth here. And on the right-hand side, we can see a plot on a log scale. So also in a very real sense, exponential, the size of these language models. So we have a plot of year over year, the number of parameters in billions for the large language models. And we can see that it is increasing incredibly rapidly. And there's just so much that's changing from year to year, from month to month, and even from day to day. The model that is state of the art may not be the same tomorrow as it is today. And everybody wants to build the next killer AI app. So uh, ChatGPT took the world by storm. It got to something like 100 million users in 10 days or some crazy feat like that. Um, the interfaces are pretty simple. They're pretty intuitive, but they allow you to interact with AI like never before, and to do things that bring a lot of value to you as the user. And everybody wants to build the next ChatGPT. So whether they're trying to build something based on computer vision or dealing with images, something like a Midjourney, they're building their own chatbot, or they're building something more bespoke. There's just so much energy and effort in the space. And here on the right, in the upper right here, we can see there's this website called There's an AI for That, which is just an entire website devoted to tracking all of the AI tools that are being developed over time, because there's just so many. There's thousands that have been at least listed on this site so far, and this is definitely not counting all of them. But the current way that people are building these AI applications, at least the way they're prototyping them and building the first iterations of them, is using, for the most part, either Gradio or Streamlit. So on the left-hand side here, we've got an example using Streamlit, which was acquired by Snowflake. And then on the right-hand side, we've got the same image that I showed of the Fuyu demo from Gradio in Hugging Face spaces. And these are fine. These definitely allow you to prototype, but they have one problem, and that is that they are model centric. So here we can see that on the left-hand side, this Streamlit app only really works with Llama 2, and sure, you could extend it to work with other models. You could kind of uh, circumvent some of the inherent limitations of what Streamlit has, and try to make it more data centric and allow people to add their own data in. But in general, it's not made for those types of things. So you're trying to fit a square peg in a round hole, and a similar thing happens for the Hugging Face spaces environments where you have, in this case, just the Fuyu multimodal model. So you've got Fuyu 8B, but it would be much harder to integrate data seamlessly into these environments and just make it more flexible and interactable for the user. And what is the problem with these apps being model centric? Well, we're in the middle of this Cambrian explosion, and the number of papers is growing rapidly, the model sizes are growing rapidly, and so too is the state of the art changing incredibly rapidly. So, this is just one particular here on the bottom. We've got this one leaderboard from Papers with Code, and this is for semantic segmentation on one benchmark, the 8020K dataset. And we can see the state-of-the-art model evaluated on this particular metric that is changing over time. We can see all of these points are models that were evaluated. We can see the points that are in this one color and are part of this curve are the state of the art over time, and it's changing, and the rate of change is getting faster. And the model that you use uh, to generate your app around may not be relevant, or it may not be the best 2 weeks from now, or a month from now, or whatever the time frame is. And on the top here, we've got just another instance of this explosion of models where on Hugging Face, there's 370,000 plus models. So, there's just so much change happening. And the models that are good today or are state of the art today may not be the ones that are state of the art tomorrow. On top of that, we've also got easier deployment options for models than ever before. So, here we've got a couple of examples for using API endpoints. So, on the left, we have replicate. So you can, via an API, call a model and basically get the results of that model in your local environment. And then on the right, we have things like inference endpoints and using fine-tuned models. So the inference endpoints is from Hugging Face, and then fine-tuned models are from OpenAI here. So you can, for the most part, with a lot of state-of-the-art or high-quality models, you can really call these models via an API endpoint and get the results locally. So that takes a lot of the difficulty out of working with models. And the same is true for serving models locally. So here's just a couple of examples. One is using OpenLLM, and then one is using Rayserve. And again, these are just a few examples, but these show just a few examples of how easy it is and how much easier it's becoming over time to serve these models and to take the model difficulty out of the equation, so that really other things become the main focus as AI apps and computer vision apps more specifically do evolve. And in reality, uh, the true source of power for a lot of these models is data. So uh, machine learning models are really powerless without data. Data is the thing that is used to train those models. It's what we evaluate the models on. It's how we understand what the models are doing, and it's really what gives us a competitive edge as we are training new models and as we are trying to create applications and to uh, build the next cool thing. In other words, data is king. So 51 is a tool set that is built to enable uh, data-centric workflows. So in a nutshell, It allows you to visualize, clean, and curate your data to find hidden structure, to evaluate models, and it is at its core flexible, customizable, and connected. So it's connected to many other tools and parts of the machine learning and computer vision ecosystems. And more concretely, you can think about it as the link between your data and models. So here's an example of data curation with 51. You can, via the UI of the 51 app, sort by properties. You can filter by whatever properties you want. You can either filter by labels or use sliders to filter by floats or whatever you'd like. You can also exclude, you can search, select, and sort. And this is just a very brief overview. There's so much functionality that I'm not going to get into here. This is just giving you a sense for what is possible and what 51 does. You can also explore and understand your data using 51. So in this case, we are doing some data exploration understanding using embeddings. So we've computed embeddings, these numerical vectors for all of the images in our data set using one particular model. And we have used dimension reduction, in this case, UMAP, in order to visualize each of the points in our data set, each of these samples as a point in a two-dimensional space. We can color by whatever property we want. We could even interact with this dynamically and select, as we're doing here, a subset of them and see the images corresponding to the lassoed points show up in the sample grid in the 51 app. We also have support for aggregate statistics and lots of other interactive visualizations. And you can do evaluation. So you can do fine-grained model evaluation with one-number metrics, all your favorite plots, as well as analysis on the level of individual labels, so individual predictions, samples, or the entire data set. Again, I'm not going to go into all of this. If you would like to dig deeper, I'll have some resources at the end that will help you to do that. And 51 supports all your favorite machine learning and especially computer vision tasks. So everything from detection to instance and semantic segmentation masks, classification, activity recognition, um, key points, relationships, and so much more. Now, everything I've showed you so far is via a UI, so it was all in the 51 app, and you were able to manipulate your data set by sliders and by clicking on buttons and this and that. Uh, the flexibility that enables all of that is made possible by the 51 Python software development kit. So everything in the app is kind of a wrapper or interface for the 51 Python query language, the Python syntax, which is essentially the core library, what you might hear referred to as the open source framework, or you can think of it as a debugger for your computer vision data. And this is effectively a Mongo non-relational database on the back end with the appropriate syntax to query and to manipulate your computer vision data. So here in this example, we can see we're importing 51. We're uh, creating a data set, we are creating a sample, we're performing some actions on those samples, adding the sample to the data set, and so forth and so on. And this Python code, the Python SDK, is incredibly flexible, and it really serves as a foundation for 51 and all of the functionality and flexibility within 51. And it allows you to do so much. So it's so flexible, in fact, that we got requests from a lot of our users, some open source, some enterprise, to build out and to incorporate a ton more flexibility and functionality into 51. And we did just that. So here's an example of adding a semantic search button into the 51 app. So here we can click on this magnifying glass and we can sort by similarity to a text prompt that we're entering. In this case, we're going to enter animals here. We can choose what similarity index we want to use, and there's support for vector databases on the back end, Quadrant, Milvus, Pinecone, and LanceDB. And you can find the samples that best correspond to that text. And this is using multimodal embeddings here and doing a query on your similarity index of image embeddings with the text embedding of the query text. So you can add a button, you can perform these custom workflows on the back end, Sometimes the functionality requests that we got from users involved building custom visualizers. So here is an example of a 3D visualizer that allows us to work with point clouds, so LiDAR and radar data, as well as 3D bounding boxes. And you can work with these in the context of groups or scenes that allow you to uh, organize your data in related media groups. So here we're actually working with a couple of images and a 3D point cloud sample from the new scenes, or from the kitty data set in this case. And sometimes it was a request for more uh, filtering functionality. So here we have a map, and this is a map that is located around Manhattan right now, and we are basically clicking and pointing to these regions to select a little uh, area within Manhattan, and we are finding all of the images within that area. And so the images corresponding to that little area that we have selected are showing up in our sample grid. So this is using geodata, and we have like integrated seamlessly with that with the visualizer for the entire data set in the same way that we had a visualization for the entire data set in the embeddings visualization we were looking at earlier. And these are just all different types of extensions that you can have to 51, and these are things that we were building in either we or some of our open source users or other users built in over time, and that's great. But something became clear, and that is that there's no way for us to build all of the possible extensions that people could want to build because the space of computer vision and AI workflows is just so large and it is growing and changing so rapidly. So something became clear, and that is that we needed to, instead of trying to build all of these, we needed to direct our efforts more towards uh, building a flexible framework for essentially extending 51 as you choose. So we directed a lot of our effort after this to building out the 51 plugin ecosystem and plugin framework that allows you to customize the 51 experience for your particular workflows. So what is this plugin framework? Well, it all revolves around operators, and operators are a term that we use to describe custom workflows that you can trigger directly from the app via forms. So this can be via a button or a panel or whatever else you'd like. They're modular, so you can uh, basically write individual operators, and then you can compose them. They're interoperable between Python and JavaScript. They have a rich type system, so there's built-in support for a large range of types, all of the types that you would naturally expect of a type system. And you can do this either asynchronously or not. And you can also delegate execution to happen either basically at a later time. So you can have everything happen in real time while you are in the app, or you can have it happen as a job that you queue and then launch later, either from this machine or from another machine. So these operators form the atomic elements or the basis for our plugin system, and you can build plugins out of either Python or JavaScript or both. So you can have custom components in panels that you define in JavaScript and really reuse TypeScript code. You can also create Python only plugins out of Python operators, or you can create plugins that have both. How are we doing on time, by the way? Are we doing all right?
Yeah, we're okay.
Yeah, everything good?
Yeah.
Great, awesome. So, I'm just gonna tell you a little bit about the plugin system, and then we'll talk about AI applications and computer vision applications that you can build using these plugins. So, uh, to start out with, we're going to look at a Hello World plugin. So in this case, we have a plugin that is a joint Python and JavaScript plugin that is built out of two operators. And every Python plugin needs an init.py file, which that registers and defines all the Python operators. So this is what the Python code looks like. We basically have a class that wraps the operator, and we can define its configuration, the input that it takes, what happens when we actually execute that operator, and what it spits out as output. And here, what is this doing? Well, the execution here is going to um, look at, okay, is the target a data set or is it a view? And then we are going to, depending on what that target collection was, we are going to return a count. So this is the sample count of either the entire data set or the specific view, the filtered view into the data set that we are looking at. This is what the TypeScript code looks like for the Hello World plugin. So this is the JavaScript part of the equation. And here we have traditional imports, and apologies if my terminology is not exactly correct. I'm not a JavaScript or TypeScript developer by trade. So this is all relatively new to me, and something that's incredibly cool about this is that you can build these plugins without really knowing a lot of JavaScript. So we export this function hello world, which has a executor that uses this operator executor for the hello world slash count samples. So basically this is using the Python operator we just defined. And that's actually what we see down here. We have, when we click on the button within the panel that we have generated, it is running this operator, this Python operator that we defined, and returning the result. And we also have a JavaScript operator that we are defining here. So this is an operator down here. This alert operator extends the class operator, and we have a config, and we have an execution, and so forth. And this is going to generate an alert. So you can also combine this in a custom component, a custom element. So here we are importing the Hello World code that we just generated into this Hello World plugin TypeScript file, and we are registering a component, basically a new panel, and you can customize this panel however you'd like. It's basically a blank canvas for you to write your own user interactions, and you can do this using Material UI, React components. You can do this using HTML, whatever you'd like. And we also have this concept of an activator. So these plugins, these panels and elements that you are creating are actually only going to be active and can only be used depending on custom conditions that you specify. And the final step for every plugin is a YAML file, which basically defines the plugin. So it gives you the plugin name, some additional details like description and version, the requirements, and then it registers or lists the operators. So in this case, we have both the Python and JavaScript operators, the count samples and show alert. That's it. This is all that you need to know to get started with the FiftyOne plugin framework and to start developing your own data-centric AI applications. So how flexible is this? Well, you can define the UI, and here we're actually looking at a plugin. This is an operator for building components, and so this is something a little bit meta because I built this UI to help other people to build their UIs. So you can, by pointing and clicking, actually decide and design what the form is that you are going to be giving users. So on the top here, we can see we're selecting between radio groups, Booleans, floats, or messages, what these different types are. Once you've selected the top level one, you can decide which of the views for each of them, which of the ways to display that particular data you want. And you can start to customize all the text, all of the hyperparameters for these things, whether they have like they're displayed as tabs or auto-completes, whether they have a minimum or a maximum value if it's a float or something like that. And you can see the code dynamically updating, and you can also see a preview of that element, and you can copy and paste that code, and you can basically plug that into your plugin code. So this is just a little bit of the flexibility that gives you an example for just how customizable all of this is, but you can go crazy with building an incredibly interactive and dynamic UI, even in Python, which is what this is. And then In JavaScript, you can build even more flexible UIs. So this is an example of building a panel that has a custom YouTube embed within it. So we can watch YouTube videos within the 51 app. You can also add your own images or audio files. You can arrange things with grids and whatever other ways that you would normally think of within TypeScript or JavaScript. And on the right here, we have the code that defines that YouTube embed. And another component of defining the UI is how things actually look within the app more generally. So you can define where things are located, so the placement of these buttons within the app. So here we can see these are the types of placements you can have. You can define them as sample grid actions or secondary actions. You can define them as sample viewer actions, embedding actions, histogram actions, and so forth. Um, and this is what it looks like for my particular app. I can see what this little icon bar looks like for me, and it's got a bunch of the built-ins. So these are the built-ins right here, and then we've got all the ones that I've defined. So these are all the plugins that I have added for my workflows. And then you can also define what the icons look like in the operator list that appears within the app. So these are all the operators that you have access to, and you can use to execute custom code. Can take some water real quick. All right, so you can write your plugins out of Python and or JavaScript. You can define the UI and make it as customizable as you want. Um, you can also define custom computations of these operators. So in this case, we are uh, basically, we created a plugin to do interpolation between text concepts. So on the top, we have the sample grid as usual, looking at the Oxford Pets dataset. And on the bottom, we have an interpolation panel, which we have generated, which has this little interpolation icon that I've created using an SVG. It's got a similarity index that you can select from. So you can select which of the similarity indices in your dataset that you want to actually use for this. You can define text concepts. So in this case, I'm defining the left prompt is husky and the right prompt is chihuahua. And then I'm going to execute this operator. When I press this button, it's going to do a custom computation for me. And that custom computation, in this case, is going to generate the clip embeddings for the left text and the right text. And it's going to interpolate between those two text prompts, the two text embeddings, with this relative strength, which we are defining. And then it is going to query our similarity index for the most similar samples, the most similar images to that vector that we have generated out of these text embeddings. So on the right-hand side here, we just have a little code snippet that shows what this custom computation is. And this is just one example of custom computation that you can do with these operators. And these computations can be incredibly scalable. So you can do things with model serving. So you can integrate with Fast API, you can integrate with Docker. We have native support for integrations with orchestration pipelines. So we have support for Apache Airflow and others. And you can use vector databases. So you can use Quadrant, Pinecone, Milvus, and LansDB to do very efficient searches of vectors to data set, um, basically up to the scale of hundreds of millions or billions. The last piece of the puzzle is that it is incredibly easy to install and manage these plugins. So here we have a plugin. This is the plugin management and development plugin. And one operator within this, the install plugin operator, allows you to decide. And basically, you can either install from GitHub or from these other tabs, which have lists of plugins that are available in the 51 plugins GitHub repo in the README there, and they're dynamically generated. So you can install any of them by just clicking on that option from the dropdown here. So You can install things really easily. You can manage them. You can look at what the required versions are. You can add as many plugins as you want at one time, and you can combine them into custom workflows. All right, so that was a lot. We've covered a lot of ground here, and we haven't really gotten into the building custom computer vision applications yet. So what does this data-centric view of the world and the 51 plugin framework and its customizability give you? What does that provide for you in terms of building these applications? Well, I'm just going to show you a few examples of what this looks like in action, just to give you a sense for what is possible. So uh, beforehand, I showed you a GIF of this AI art gallery plugin as well. So this is you could call it a text to image plugin. You can choose between Stable Diffusion, STXL. Now we've added support for SSD 1B and latent consistency models, as well as Dolly 2 and VQGAN clip, or sorry, feedforward VQGAN clip. Um, you can you can basically specify the prompt. You can specify a negative prompt for some of these. You define what the hyperparameters are, the scheduler, number of inference steps, and so forth. And you can add the image directly to your data set. And then if you don't like it, then you can decide to get rid of it. You can delete that and you can move forward. And the cool thing is you are retaining the information about the hyperparameters and what the configuration you use to generate these things are as you're going. And then you can filter by all of those properties moving forward. So you can build out custom AI art galleries um, incredibly easily. Here's another example. So something that's very popular these days is reverse image search. You might have seen a lot of demos, a lot of Streamlit apps that do things like this, but this is a much more native and sensible way of doing this, where you have the data comes first, and you can drag and drop whatever image you want into the panel, either from a URL or from your local file system, and search for the specified number of similar samples in your dataset. So this is incredibly easy to do. In just a few lines of code, you can create a reverse image search application. And you can do this with any of your datasets. You can switch and toggle between your datasets with a couple of clicks, and then you could do a reverse image search on another dataset with the same image. So incredibly flexible here. You can also do cross-modal retrieval. So this is similar to reverse image search, except in this case, you can use a different modality of data as the input and find the samples that are closest to that input. So here, hopefully this YouTube video will play. So here we are selecting an audio clip. It's an audio clip of a train chugging along. We are searching for the most similar images to that audio clip. Again, very simple, but this just shows you a sense for what is possible here. You can work with lots of different modalities. And in this case, we're using image bind. So this is a model from Meta that it basically builds itself as one model to rule them all. It's got support for, I think, 5 or 6 different modalities all in one. You can also do things like concept space traversal. So this is something that I was obsessed with for a long time. Um, you can start with some image, which you select from your dataset, and then you can add in text concepts one by one and dynamically choose the strengths that you are adding those text concepts at. And uh, as you do so, as you update any of these parameters, you will dynamically search your dataset for the most similar images to this unique combination of image and text concepts. And on the back end, it is every time it refreshes, it is taking the new vector that you have defined with these relative uh, contributions from text and image, and it is doing a query against a similarity index associated with your images. So here we are taking a pizza and we are adding healthy and colorful to it in some combination, and we are seeing the result, which is a fairly healthy and fairly colorful set of food items. You can also do things like semantic document search. So this is something that has also been very popular recently, and for good reason. So here we can add in, for instance, I'm adding in my thesis here just for show. This is my PhD thesis, and we have used a plugin called the PDF loader plugin to load in all of these PDF pages as images. Then we have generated a semantic index on the text blocks, which we have generated using OCR. So there's actually three plugins here. There's the PDF loader plugin. There is the OCR plugin, which allows us to generate these localized blocks of text for our documents. And then we have semantically generated an index and are searching the pages and the blocks in those pages of our PDF documents incredibly easily via like a simple UI here. And you can add whatever PDFs you want. These can be either things like, in this case, a thesis, or they can be medical records or legal documents, handwritten notes, old contracts, whatever you'd like. And probably the coolest thing about all of these plugins is that you can mix and match them, and you can combine them to create more interesting workflows than you would with just a single Streamlit or Gradio application that is built for one particular purpose. So in this is just one example of how we can combine a bunch of plugins together to create new cool workflows. So here, I'll wait for it to start again, but we're combining three together. So we start out by using the AI Art Gallery plugin. We are using a text-to-image model to generate an image from a text prompt. Once we add that image to our dataset, we are using the Fuyu8B model, and we are asking a question. So we're asking it to describe the scene for us, and it is going to generate this really detailed description. And then we are using a zero-shot prediction plugin and specifying the label classes, pillow and lamp, and it is generating segmentation masks for the pillows and lamps in our image right then and there. So again, this is just one example, but it shows you just how nuanced and creative you can get by combining plugins. And the last thing I want to show you is a plugin that we built to help you to make the on-ramp into FiftyOne as easy as possible. And this is VoxelGPT. So it is an AI assistant for computer vision. It helps you to explore your data via chat, not code. You can search the documentation. You can get answers to your complex machine learning and computer vision questions. And all of this is implemented as a plugin in FiftyOne. So you can explore this. Here, let me go back here. You can use this if you go to try.51.ai, then you'll be able to use this. And here it's going to show you just a little bit of how this works. And you can also install this locally. So what's going on here is it's a wrapper around a large language model. In this case, we're using a GPT model, and we're asking it to show all the animals in the data set. It is determining your intent, finding the relevant structure in the data set, and then filtering the data set for you and evaluating that code to give you the subset of your data set that you want. And now you can have a conversation with it. You can ask it to show you object patches for predicted bears here, and it's going to do that. It's going to refresh and give you those examples. And you can continue this conversation. You can mix and match questions about the data set, about the entire FiftyOne query language, or questions that are just general machine learning and computer vision questions. So here we're asking it a question about the FiftyOne query language, and it's going to search the FiftyOne documentation. It's going to give us a result based on that with sources, of course. And now it's going to generate the answer for a question about general machine learning and computer vision formats and knowledge. So it's going to tell us what the most common bounding box formats are. And this is all implemented as a plugin. And if you want to check out this plugin code, you can go to the GitHub repo for it, which is open source, like everything I showed you today. So this is github.com/voxel51/voxelgpt. And this is probably the most in-depth and extensive plugin that we have, but it just gives you an example of how flexible this framework is, allowing you to build out your own custom AI and computer vision applications. So that's all I have for you. Just want to conclude with some next steps. If you liked the talk today, and if you're excited by the 51 project and using 51 plugins to build your own custom computer vision applications, then we'd really appreciate if you could go to our GitHub repo and give us a star. It's an open source project, and this helps us to keep on going. Would also appreciate a follow on LinkedIn. And if you want to try out VoxelGPT or play around with data sets that are publicly accessible, go to try.51.ai, which you can get to by basically scanning this QR code right here. And you can get started working with plugins and playing around. Also happy to provide I will give the links to Dimitro and he will pass them along, how to get started working with 51 plugins. And I'm sure these slides will be made available as well. So that's all I have. Thank you so much for your time. I really appreciate it. And I appreciate you sticking around.
Yeah, thank you for your presentation and overview of Voxel 51 and what products you're doing on it. I have one question about 51. Do I understand correctly that it's more for working with dataset and with models which you have, your own models? I cannot add my model in this system.
You could definitely add your own model. So most of what I showed you was using models that I added as a third-party user. So you can add them either locally. You can define your own model by basically wrapping a Torch, TensorFlow, or sklearn model in a class for a 51 models. All you need to do is define the predict method. You can also get the results of models via API. So sometimes I was using replicate or OpenAI API keys and calling those models. There's a ton of flexibility here. You can also, if you have the predictions already, you can just add those predictions as fields on your data.
Okay, yeah, and for example, I built some plugin and do some search. Can I publish this solution as API maybe, or somewhere where? What will be the next step after creating something in your platform?
Great question. Just want to make sure my screen is still sharing with everybody. So this is the 51 plugins repo right here. So this is the home for all things 51 plugins right now. And if we scroll down, there's these core plugins. There's Voxel 51 plugins, which has the Voxel GPT that I showed you. And then there's this list of community plugins, which is plugins that are generated and contributed by community members. And all you need to do here is submit a PR to the 51 plugins repo, adding an entry to this table with your particular plugin, and this will link out to the GitHub repo for the plugin that you have defined. And then it will be available to install for everybody via the 51 app, because that 51 management and development plugin, it dynamically refreshes with all of the entries in the README. It's basically parsing the tables in the README to get all the plugins, and it gives the users of the app all those as possibilities to install without even writing any code.
Mm-hmm. Yeah, so it's for public plugins, and if I want to have my own private,
yeah, if you want to do your own, then all you need to do is you have a 51 plugins directory on your computer, and all you need to do is to add your subdirectory with your YAML file and your init.py file, and if you have them, your TypeScript files, to that directory, and it will automatically be registered by 51 as a plugin on your particular computer, and it will not be published to the world.
Oh, okay. Yeah, we also have several more questions. Um, are there any plans to extract this amazing functionality to NLP-oriented data model based uh, on text data?
Uh, Great question. So we do have some support for text data right now. So there, I showed you some OCR or semantic search type stuff. There's some stuff related to image captioning, and then we have some support for audio. But in general, right now it is mostly image video point cloud, but that is not going to be the case forever. So there is definitely an interest from a large part of the community in extending the functionality to other types of data. And that is something that we are thinking about very deeply. I can't share too much more than that, but it is definitely something that we are excited about.
Yeah, and more one question about customization of interface. Is it possible to change the color of the buttons or change between light and dark mode?
Yeah, so you can definitely change the color of the like the icon in the buttons. So you can define whatever colors you want for that. And then you can also choose light or dark mode. So you can specify that in your app config settings. So if you import 51 and then you look at the 51.app config, then that should be available. You can also have it just match your system settings. So you can if you have dark mode or light mode on your computer, by default, it will use whichever one of those.
Yeah, cool. Yeah, so it's possible customize as you want. Good. Thank you for this very interesting presentation again. Thank you for all who was with us today. We'll see all you on the next webinars.
And thank you so much again for having me. I really appreciate the invitation, and it is a pleasure to be here and to get to be a part of the Data Phoenix community.
Yeah, thank you. If you will have the question in the future, please ask the question in our Slack channel, and we will be happy to answer for them. Thank you. Bye.